Number 12. The image of triangle ABC. So as soon as you see the word image, you should be thinking some sort of transformation is happening. The image of triangle ABC after a rotation of 90 degrees clockwise. So right, you got a clock, 12, 1, 2, 3. Clockwise is that direction. Right, that's clockwise. About the origin, it produces triangle DEF, this triangle here. So this is the image, this is the original, and then they say, look, which of these statements must be true? And what you need to recall is that when you do a rotation, that is a rigid transformation. That means corresponding sides are congruent and corresponding angles are congruent. If this was a dilation, sides would not be congruent, only the angles would be. But we're not talking about a dilation. This is really like, hey, this entire shape is congruent to the image. The trap in this is that you need to only say the corresponding sides, because clearly BA is not the same length as a different side. So it becomes a question of, well, how do you know what corresponds? And that really comes from what they give you, that written statement. You've got triangle ABC. Because it's a rotation, you know that's congruent to the other triangle, and you have to go off of what they call it. They call it triangle DEF. And right there, that statement is going to allow us to check each of these answers. And I'll just go from the top down. And what they're saying is, I guess I'll do it in green, side BC, right? So the last two letters. They're telling me it's got to be congruent to DE. But if I look at my congruent statement, I know these last two letters need to be congruent to the corresponding last two letters. So BC is really congruent to EF, and that's not what they have here. And that's why this is false. That's why it's not true. So I'm going to go through the next one. I'm going to see if I can rule it out or if that really is our answer. So here they're saying AB, okay, the first two letters. Well, the first two letters need to be congruent to the corresponding first two letters. So it's AB is congruent to DE, right? AB is congruent to DE. And that's not what we have here. We have DF. So that can't be our answer. We got to get rid of it. And now it's just a matter of the angles. The angles are easy. It's just one letter. So they're telling me angle C. Okay. This last letter, well, that needs to be congruent to the corresponding last letter. That's got to be congruent to angle F. And that's not what they got, right? They're saying angle E, and that's just not true. And I bet you this last one is going to be our answer. Because look, it wasn't 1, it wasn't A, it wasn't B, it wasn't C. It's got to be this. And I'll even check it. Look, they're saying angle A, that first angle. Well, I know angle A has to be congruent to the corresponding first letter in the other triangle. And that is the last statement. Angle A is congruent to angle D. And that's why this, D, is your answer for this. So to kind of recap, whenever they talk about transformations and they're rigid, meaning they're either translation, rotation, or reflection, you kind of want to look at the congruent statement if they're going to ask you something like this, like what pieces are congruent. I'll see you in the last problem.